right, so we said that we would pick up with the slope of a line. Let's do that now. The slope of a line running through 2 points, x1, y1, and x2, y2 is m, where m equals change in y over change in x, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Huh? That's fancy math formula speak. What is this talking about? Look, what it's saying is that there are 2 points here. Distinct means different, okay? There are 2 points. One is the first point. So the x and the y that belong to the first point, we're going to call x1 and y1. And then there's a second point, and we'll call those x2 and y2. So y sub 2 is really just the y from the second point. X sub 2 is the x from the second point. Y sub 1 is the y from the first point, and x sub 1 is the x from the first point. So all the formula says is you do the change in y over change in x, which is the y from the second point minus the y from the first point. That'll give you the difference or the change in the y, over the x from the second minus the x from the first. That will give you the change in the x. So it's the second point minus the first point over the second point minus the first point. Now what that's really important for is it makes sure that you keep the order of the points the same. If you don't keep the order of the points the same, the slope will always be the negative of what it's supposed to be, okay? So that's the importance of using those sub 2s and sub 1s. And remember, it just means the y from the second point minus the y from the first point over x from the second minus x from the first. So let's show you how we put this all together in a particular question, okay? Find the slope of the line containing negative 1, 2 and 2, 6. Now, what I can do for this particular slope is I could, this is just like the one we did before, negative 1, 2 and 2, 6. I could, if I wanted to, I could mark the points. Negative 1, 2, 2, 6. I could, if I wanted to, draw up 4 over 3. And then I could conclude that the slope was 4/3, just like I did before. Exact same question. Or, rather than draw the red points, rather than set up the actual grid for the graph itself, rather than draw the up 4 over 3 or count the up 4 over 3, I could just use this formula. Y from the second minus y from the first over x from the second minus x from the first. Now, it makes absolutely no difference, zero difference whatsoever, if you use whichever point you use for the first and the second point. I tend to use the second one that they give me second and the first one first. It makes no difference whatsoever as long as you keep the order the same. So the y from the second point is 6. So I'm going to do 6 minus the y from the first point, which is 2. And that's where I get the numerator, which says 6 minus 2. Now for the denominator, I'm going to take the x from the second point, 2, minus the x from the first point, negative 1. And that's 2 minus the whole thing of negative 1. Make sure you put down a negative 1 in there for x sub 1 or x1 or x from the first point. 6 minus 2 is 4. 2 minus negative 1 is 3. So either way, I get that the slope is 4/3. And you can do it, it's quicker to use the formula, okay? Which is the great advantage to the formula. And we're going to talk today about using the formula more and more. But I would like to take a step back before we go through some more formula examples and just talk about the possibilities for finding a line slope. Remember, we always go left to right. And if you're having an up day, you're having a positive day. So going left to right, the slope of this line goes up. So that's an example of a positive slope. Up day, positive day. Now, if you're having a negative slope, the slope is going down because it's a negative day. And if you're having a negative day, you're having a downer of a day. Now, the zero slope, if a positive slope goes up and a negative slope goes down, so we would have like a positive going up and a negative going down. What numbers between the negatives and the positives? 0. So this is a zero slope. It's horizontal. It's not positive. It's not negative. It's in between. Okay? And if you have an undefined slope or no slope, that's the perfectly vertical line. Right? With a positive slope, you're walking up the hill. With a negative slope, you're walking down the hill. With a zero slope, you're not walking up or down. You're just on flat land. Undefined slope, you go ahead. You try walking up that. There is no slope upon which to walk. All right. So that's a summary of what the slope possibilities are. You should know those. Okay. Now we're going to go through 6 examples of finding the slope of a line, okay? I'll take you through the first one using the formula, and then we'll do example for example, one at a time for the rest of the page, okay? All right, so for the first one, the slope is equal to the y from the second minus the y from the first over the x from the second minus the x from the first. So the y from the second point is 4 minus the y from the first point, which is 1. So that's where I get my 4 minus 1 from. And the x from the second is 4 minus the x from the first, which is 5. So that's why it says 4 minus 5. And if I do that, I will get 4 minus 1 is 3, 4 minus 5 is negative 1, the slope is negative 3. Now, let me just show you that if you reverse the order, you get the same slope. If I did reverse the order, 1 minus 4, I get negative 3, 5 minus 1, I get positive 1, and I would also get negative 3. So it works the same. The one thing you can never do is switch the order. If I start with the 4 point, I have to start with the 4 for the y and the 4 for the x. If I start with the 5, 1, I must start with the 1 for the y and the 5 for the x. What I can never, ever, ever do is start with, say, the 1 for the y here, and then reverse the order and do the 4 for the x. That'll get me the negative of the answer every single time. Okay, you try 2, 2, and 3, 7. Do stop and start, of course. Okay, so again, I always like to start with the second number first. Okay, so I'm going to go, and here's the formula up here in case you're forgetting it. Y from second minus y from first, x from second minus x from first. So 7 minus 2 over 3 minus 2. 7 minus 2 over 3 minus 2. 7 minus 2 is 5. 3 minus 2 is 1. That slope is 5. Oh, let me go backwards there for a second. Okay, you try the next one. 0, 1, and 3, 8. Do stop and start. Okay, so 8 minus 1 over 3 minus 0. 8 minus 1 is 7. 3 minus 0 is 3. Now, isn't this easier than actually getting a grid, plotting points on the grid, counting up and counting over? It's just much quicker and much less handwritten work to do. All right, let's try the next one, which is negative 2, 1, and 1, negative 3. Go ahead. All right, I was just yawning on my own there. So we're going to get negative 3 minus 1 over 1 minus negative 2. Negative 3 minus 1 is negative 4. 1 minus negative 2 is 3. So negative 4/3 is the correct answer. Okay, try the next one. Okay, so when I subtract the y's, I get 5 minus 5, there it is, 5 minus 5, over negative 1 minus negative 3, which is 0 over 2. I have to go backwards, I didn't want that up there. Which is 0 over 2, which is 0. So that's a slope of 0. Okay, let's try the last one, 2, 7, comma 2, negative 7. Go ahead. Okay, so I'm going to get negative 7 minus 7 over 2 minus 2. And then that is negative 14 over 0. And you're not allowed to divide by 0. That's called undefined. So no slope and an undefined slope, same exact thing. All right, this is the perfectly vertical line that would go, in this case, through x equals 2. Okay? All right, so let's go back and show you how this is a little bit quicker again than before. This is the other slide that we did earlier on. We said find the slope of the line containing negative 3, 4 and 2, 1. And we said, okay, well, we could. First, we'd have to plot the point. Well, first, we'd have to actually get a grid to graph on. Then we'd have to plot one point, plot the other point, draw the line connecting the two of them. Then we would need to be able to count boxes, which means I need to go down 3 and over 5. That gets me a slope of down 3 over 5. And it gets me a slope of negative 3/5. So I could do all of that work. And keep in mind, I'm just pressing buttons on a PowerPoint program where I actually already recorded all of this information. I think it's a little bit quicker and a little bit easier to just use the slope formula. This time I did the first point and then the second point, but it doesn't make a difference. 4 minus 1, negative 3 minus 2. 4 minus 1 is 3. Negative 3 minus 2 is negative 5. The first slope was negative 3/5 because you go down 3 over 5. If you just use the formula, negative 3/5 either way. And believe me, over time, you can do this formula without writing it down. You could just do it in your head every single time if you're really concerned about doing it as quickly and as easily as you possibly can. All right, so that's a video on how to find the slopes of lines. Next, we'll start talking about linear equations.